So here are some quirky examples. So BeF2. Beryllium is a metal. This is a non-metal. So this one's kind of tricky. You're like, are they even sharing? Kind of. So we could say that beryllium is sharing with fluorine, and then we could do that. However, in reality, beryllium is giving those electrons away mostly to fluorine, and so our better Lewis dot structure would be an ionic one. Good. So how about N2, this nitrogen gas molecule? So nitrogen is N2. Each nitrogen atom has 5 valence electrons. I have 2 of them. That's a total of 10. Things are about to get crazy, my friends. So I'm going to give those 2 nitrogen atoms a pair of shared electrons. There's 2, 4, 6, 8, 10. This is a problem. I have one nitrogen that's super happy and one nitrogen that is definitely not. So what I'm going to do is actually move one of these shared pair or not shared pairs, and I'm going to make it extra shared. This is a double bond. So now this nitrogen still has 2, 4, 6, 8. That's good. This nitrogen 2, 4, 6, we're so close. I'm going to go ahead and steal one more pair of electrons here, and we're going to share it one more in the middle. So now, this is so cool. Nitrogen, this guy has 2, 4, 6, 8. 2, 4, 6, 8. This nitrogen also has 2, 4, 6, 8. And that is a triple bond because there are 1, 2, 3 pairs of electrons. 1, 2, 3 pairs of electrons between those 2 nitrogen atoms. All right, let's do this one together. Hydroxide polyatomic ion. So it's OH with a charge of -1. Oxygen has 6 valence electrons. Hydrogen has 1 valence electron. This charge of -1 means that these guys worked together to steal one more electron. So our total number of electrons is 8. So I'm going to draw my O and my H. The first pair of electrons is going to go between those 2 atoms. And now I'm just going to fill in around my oxygen. There's 2, 4, 6, 8. I'm not going to give any more to hydrogen. Hydrogen is happy with just those 2. Oxygen does need 2, 4, 6, 8. Hydrogen just needs those 2. This is good. The quirky thing to remember is because this is an ion, we're going to go ahead and put it in brackets and add the charge. Same thing for this guy. So let's do this one. So this ion is called hydronium. So H3O with a +1 charge of hydronium. So each hydrogen has 1 valence electron. There are 3 of them. Oxygen has 6. And then this means that we actually lost 1 electron. So 1 times 3 plus 6 is 9. Whoa! 9 minus 1, narrow down. We're back to only 8 electrons. Oxygen's going to go in the middle because hydrogen never, ever, ever, ever goes in the middle. 1, 2, 3 hydrogen atoms. We're going to fill in electrons in pairs being shared between the atoms 2, 4, 6. To get to 8, I'm going to give oxygen that last pair. Double check to make sure everybody's good. This hydrogen has 2. This hydrogen has 2. This hydrogen has 2. And that oxygen has 2, 4, 6, 8. Voila. Because it's an ion, we do need to put the whole thing into brackets and add that charge. Let's do one more together, and then we'll let you work a little bit on your own. So this guy, C2H6. So C2, I'm going to put those 2 guys in the middle. H6, I'm going to spread those H's around my C's. Good. Carbon has 4 valence electrons. There's 2 of them. That makes 8. Hydrogen has 1 electron. There are 6 of them. That's a total of 6. Add those up together and I've got 14 electrons. We're going to always start with shared pairs. Share a pair between the carbons, between that carbon hydrogen, that carbon hydrogen, that carbon hydrogen, this carbon hydrogen, and here, and here. Let's see how many I've drawn. 2, 4, 6, 8, 10, 12, 14. There are my 14 electrons, and this is perfect. So I have my 2, 4, 6, 8 around this carbon, 2, 4, 6, 8 around this carbon. Hydrogen has 2, hydrogen has 2, hydrogen has 2, and 2, and 2, and 1 last hydrogen with 2 valence electrons. Voila, we've done it. Let's do one more together, and then I'll let you finish these 2 on your own. Good. So NH4 with a +1 charge. Nitrogen's going to go in the middle. Hydrogen is going to go around it. Nitrogen has 5 valence electrons. Hydrogen each has 1 valence electron. There are 4 of them. 5 plus 4 is 9 electrons, but that charge of +1 means that I lost 1, so we're down to 8 valence electrons. I'm going to put them between my pairs. I put the shared pairs between the atoms first. There's 2, there's 4, there's 6, there's 8. We have run out of electrons. What do we do? Actually, we don't do anything. We're done. I've got 2, I've got 2, and 2, and 2. And then looking at that nitrogen, there are 2, 4, 6, 8 around the nitrogen. Remember, because this is an ion, we're going to go ahead and put the whole thing in brackets with the charge on the outside. Go ahead and do S and T on your own, and then come back and check your answers.